What if the universe isn't just expanding, but slowly losing the ability to remember its own past? Not metaphorically, because every second, cosmic expansion is carrying distant regions of the universe farther beyond our reach. And entropy is making the precise details of the past harder and harder to reconstruct. The strangest part? The universe doesn't necessarily have to destroy information. It may only need to make that information unreachable. And if cosmic expansion continues for an unimaginably long time, there could come a point when almost everything we know about cosmic history becomes invisible to future observers. So, is the universe slowly forgetting? Before we go any further, there's an important distinction. When we say the universe is forgetting, we don't mean that the laws of physics contain some cosmic delete button. Physics doesn't currently tell us that the universe simply erases its memories. Instead, something much stranger can happen. Information can become inaccessible. Imagine writing a message on a piece of paper, and then throwing that paper into an ocean. The message still physically exists, but for you, it has effectively disappeared. Cosmology gives us a version of this on a scale so enormous that it's difficult to comprehend, because the universe isn't sitting still. Space itself is expanding, and that expansion changes what information can ever reach us. When we look into space, we're also looking into the past. The farther away something is, the longer its light has taken to reach us. The night sky is essentially a gigantic archive of cosmic history, but there is a limit to how much of that archive any observer can access. Because the expansion of the universe isn't simply carrying galaxies farther apart. On sufficiently large scales, the expansion of space can prevent light from distant regions from ever reaching us. This creates what cosmologists call a cosmological event horizon. Beyond this horizon, there can be events whose light will never arrive here in the future. Think about what that means. A galaxy could still exist. Stars could still be exploding. Planets could still be orbiting distant suns. And civilizations could potentially be doing things right now, while their information becomes permanently inaccessible to us. Nothing necessarily has to destroy them. The universe can simply place them forever beyond our cosmic reach. There's another strange consequence. When you look at the night sky, you might imagine you're seeing the universe as it currently is. You're not. You're seeing ancient light. The sun appears roughly 8 minutes in the past. The Andromeda Galaxy appears roughly 2.5 million years in the past, and the most distant light we observe comes from an era when the universe was vastly younger. In a sense, astronomy is the science of reading the universe's historical records. But those records aren't permanent. As cosmic expansion continues, some sources become increasingly difficult to observe. Eventually, in a far future universe dominated by accelerated expansion, many galaxies that are visible to us today could become unreachable to future observers. Imagine being an astronomer trillions of years from now. You look into the sky, and the universe appears almost empty. You might see only the gravitationally bound structures close enough to remain accessible, and the evidence for a much larger cosmic history could be fading away. But cosmic expansion isn't the only reason the past can become difficult to reconstruct. There's another force quietly shaping the story: entropy. The second law of thermodynamics tells us that in an isolated system, entropy tends to increase. But what does that have to do with memory? Consider an egg. An intact egg contains an enormous amount of organized structure. Drop it, and it shatters. The pieces don't contain some magical missing information. The information is distributed through countless microscopic details. Where exactly did every fragment go? How did every molecule move? What was the precise state of every particle? In principle, the microscopic state contains information, but reconstructing the original egg from the shattered pieces becomes practically impossible. This is one way to think about entropy. The past isn't necessarily being deleted. Its information becomes increasingly dispersed and difficult to recover, and the universe is doing something similar on an unimaginable scale. Now we reach the dangerous part of this idea. Does increasing entropy actually mean the universe destroys information? Not necessarily. In modern physics, especially quantum mechanics, fundamental evolution is generally expected to preserve increasingly inaccessible to practical observers. Entropy destroys the past. The microscopic details may still be encoded in incredibly complicated correlations, but recovering them could require knowing an absurd number of variables with extraordinary precision. And once we combine this with cosmic expansion, the problem becomes even stranger. Some information isn't merely difficult to reconstruct, it may become permanently outside our causal reach. That gives us two very different kinds of cosmic forgetting. One is caused by complexity and entropy, the other comes from the structure of space-time itself. And then physics gives us an even more disturbing question. Black holes. If you throw something into a black hole, what happens to the information describing it? This question created one of the deepest problems in theoretical physics, the black hole information paradox. Black holes can evaporate through Hawking radiation, but if the black hole eventually disappears, what happens to the detailed information about everything that fell inside? Is the information truly destroyed, or is it somehow encoded in the outgoing radiation? Decades of theoretical work have strongly influenced the modern view that fundamental information should not simply vanish. But exactly how that information is preserved and recovered remains a deep subject of research. And this brings us back to our original question. Maybe the universe doesn't need to destroy information to make its past effectively disappear. It only needs to scramble it, disperse it, or place it beyond the horizon of every possible observer. Now imagine pushing this idea unimaginably far into the future. Stars eventually exhaust their fuel, galaxies change, stellar remnants dominate. Black holes may become some of the last major sources of astrophysical activity, and on vastly longer timescales, even black holes may evaporate. The universe approaches a state of extreme thermodynamic equilibrium. This scenario is often associated with the idea of heat death. It's important to understand what this doesn't mean. It doesn't mean the universe suddenly becomes absolutely empty. It means that usable differences in energy become increasingly scarce. Without large energy gradients, there is less capacity to drive complex processes, less structure, less activity, less opportunity for observers to reconstruct what came before. The universe could still contain the physical consequences of its history, but the cosmic evidence may become increasingly difficult to interpret. And here's where the idea becomes genuinely unsettling. The universe doesn't have to forget its past, for its inhabitants to forget it. Imagine a civilization billions or trillions of years from now. Suppose they look outward. They may have access to only a tiny fraction of the cosmic structures we see today. They might have little observational evidence that the universe was once filled with countless galaxies racing away from one another. The cosmic past could become scientifically difficult to reconstruct, not because history was erased, but because the evidence needed to reconstruct it disappeared beyond their horizon. In that sense, cosmic expansion doesn't merely change the future, it can change what future observers are capable of knowing about the past. So, is the universe slowly forgetting? Scientifically, we shouldn't say that the universe has a literal memory that is being erased, but something remarkably similar can happen. Expansion can place information beyond our cosmic horizon. Entropy can disperse information into increasingly complex microscopic states. And the far future may contain dramatically less accessible evidence of the universe we see today. Which leads to a final thought. Right now, we can look into the night sky and read billions of years of cosmic history. But the universe may not preserve that view forever. The galaxies won't necessarily disappear. The past won't necessarily be destroyed. The evidence may simply become unreachable. And perhaps the darkest thing about cosmic time is this. The universe may keep its history forever, while slowly becoming incapable of telling anyone what happened.